All right, so we've always got to be thinking about what we've got here. So if I'm looking at this one here, this 2 I can pull on the outside. That's not a big deal. So if I'm looking at 1 over the square root of 1 minus x squared, about now you're remembering that that is arcsine. So this is equal to arcsine of x plus c. So you've got to just know that. All right, this one here is not arcsine because of that x up here. So if I was to separate this, see the 3x dx off to the side, I'm thinking that a u substitution would be useful here. So I'm going to let u equal the inside of the radical. So du is negative 2x dx. So I see that I've got an x dx and an x dx, and I've just got some numbers to work with, right? So I can pull that negative 2 over here to be negative 1/2 du is x dx. And this here, I can pull this 3 on the outside of the integral. So I'll get the 1 over the square root of u, and x dx will get replaced with negative 1/2 du. All right, so let's clean it up and pull that negative 1/2 outside. And then let's rewrite the 1 over the square root of u as the exponent that it is. Now let's integrate by adding 1 to the exponent. So I get u to the 1/2 over 1/2, or times 2, plus a c. And so now cancel the 2's and put the x's back in. So I get 1 minus x squared to the 1/2 power plus c. All right, looking at this one, if I let u equal the inside of the radical, I get negative 4x cubed dx. All right, I only have an x up on the top here, not an x cubed. So you can never move x's over to this side. So never make it du over x cubed or anything like that. So never do that. So this u substitution is not going to work. So I need to think of something else. So we've just played with arcsine. And I'm going to rewrite this. So all I've done is move the x and the dx over to the side. And I've rewritten the x to the 4th as x squared squared. Now, because I know of how u substitution works, I'm going to suggest that we let u just equal this inside x squared. This is a clever trick that you're just going to have to get familiar with, because it is a difficult thing to recognize to do. So now I'm looking at, oh, x dx. That is what I have, right? Except for this 2 here. So let's move that over to the other side. So I get 1/2 du is equal to x dx. All right, let's do the substitution. So x dx gets taken care of with a 1/2 du. And inside the radical here, I have 1 minus u squared. You recognize this as arcsine. So this is 1/2. And then I see this is going to be arcsine of u plus c. And then put the x's back in, which is x squared plus c. All right, so everyone's its own fun adventure. So this was a challenging one, being a clever trick that I'm just going to want you to practice to get to know. 1 more, or 2 more. So let's let u equal the inside of the radical. It's a very common thing. So du is negative 1 over x dx. All right, if I'm looking at this, take the time to rewrite it. 1 minus ln of x, 1 over x dx. So I see that I have this right here. So negative du will be take out 1 over x dx. So I have the 1 over the square root of u, and then negative du. Make sure you put parentheses there so you know that that negative sign is multiplied. So then rewrite it as the exponent that it is, so that I can take the antiderivative. So I'll get 2 u to the 1/2, and then don't forget to put the x's back in. All right, one last one on this page. So by saying this is the derivative, they're asking me to find the antiderivative, which is like the integral, and this is the information that'll help me find c. All right, so if I'm going to be taking the antiderivative of this, I'm going to need a u substitution. So because there's no way I can do it any other way. Let me just rewrite it, though, so we can separate it, so we can perhaps see what I have, right? That's the same thing. So I'm going to let u equal pi over x, and let's rewrite that as pi times x to the negative 1. Pi is just a constant. I'm going to carry it along. So I get negative pi x to the negative 2. So this is the same thing as saying x to the negative 2 gives me over x squared. So it's almost there except for the pi, or in the negative pi. So negative 1 over pi du is 1 over x squared dx. All right, let's substitute it in. So I have cosine of u, and then I'll have negative 1 over pi du. So let's pull that negative 1 over pi out in the front. Then I'm just left with the integral of cosine, which I know is sine. And then take a moment to put the x's back in. Sine of pi over x plus c. So that's the antiderivative, so that's f of x. So now I get to use the fact that f of 2 equals 4, which means x is equal to 2 and y is equal to 4, or f of x is equal to 4. So I have 4 is equal to negative 1 over pi sine of pi over 2 plus c. So I know sine of pi over 2 is 1. So then I'm going to add 1 over pi to the other side. So that's c. Okay, so the final answer is f of x is equal to negative 1 over pi sine of pi over x plus 4 plus 1 over pi. You're going to get ugly answers for c, you just got to get used to them.